suppose that in the city the wholesale price P of oranges in dollars per crate and the daily supply X in thousands of crates are related by the equation P of X plus 7X plus 8P equals 328. If there are 4,000 crates available today at a price of $25 per crate and the supply is changing at a rate of negative 0.3 thousand crates per day, so in other words it's going down because it's negative, what's the rate of the price changing? So to do this, we need to take the derivative. This is a related rate, right? This is actually over time. So in this case, both P and X are going to keep their rates with them because we're actually differentiating with relate to time, because time is what we're going. So we want to know how it's changing with relate to time. So when we take the derivative of this, so I'm going to take the derivative of this equation right here, okay? I am going to start this P of X, they're both variables, they're both things that are changing, nothing's a constant, therefore I have to do the product rule. So I have the first times the derivative of the second, which is 1, but then I have to do dx dt because it's not over dx. I'm not differentiating, I'm differentiating with time. Then I'm going to do the second one. So this is going, I'm going to keep my x, but then it's going to be 1p and then dp dt. Okay, so that's the first one. Then here, this is going to be 7 dx dt, and then 8 dp dt, and then this is just a constant, so that's 0. Now at this point, I want to get my dx dt's on one side and my dp dt's. So you can see these two, they're going to come together. So I'm going to have p plus 7, I'm going to factor out. Okay, so all I've done, put those together, factored out the d of x. Now I have to move these next door, so I'm going to have a negative x dp dt and a negative 8 dp dt. So I have p plus 7 dx dt equals negative x minus 8 dp dt. Okay. Now I'm going to put in the information I've been given. Okay, so I had to take the derivative. Now I've got to put in the information that I was given. So P, I was told, was 25. My supply rate, which is dx, so looking up here, okay, so this right here, this is P, here's x, so they told us what x and y are, and this here, this is rate if the supply is changing, which is x, this is dx dt. So this is negative 0.3, okay? And then over here, this was negative 4 minus 8, because this was 4. And then I don't know what dp dt is. That's what I'm trying to solve for. Okay? Now, what am I going to do next? I'm going to clean up. So I'm going to add those together, times it by this. Negative 9.6. This is negative 12. And yes, I did that on calculator. I did not do that on my head. Okay? Same thing. Get out my calculator. dp dt equals 0.8, because the two negatives cancel each other out. That means the price is increasing by 80 cents a day. That's what this tells us. So the supply is decreasing, okay, by 0.3 thousand crates a day, but then the price is increasing, which makes sense. As supply goes down, price is going to go up. So hopefully this helps you. The big thing with all these is you have to keep track of all the different pieces. Nothing kind of goes away the way we're used to. So I have to have those differentiation factors, these right here, in each piece. And I have to keep which one's different.